Hello there. So, to solve this problem, we first need to draw the forces acting on each of these balls. So, we know that the only forces that are acting on this are the tension and the weight. Also, we know that applying Newton's second law, we obtained that the sum of forces is equal to the tension minus the weight. But we know that the system is moving upward with a positive acceleration, so that this is equal to m times the acceleration. So knowing the definition of the weight, which is that the weight is equal to the mass times the acceleration due to gravity, we obtain. And then solving for the tension, we find that this is the expression for the tension in any of these masses. We know that the lines attached to the 2.05 and 2 kilogram masses do not break, but the others do. So, since the string broke for the 2.10 kilograms mass, we know that the required tension to accelerate that mass was more than the acceleration force, that is 22.2 newtons. So for that, we will obtain this condition. The mass of the tension must be less than the product of the mass of 2.10 kilograms times the acceleration due to gravity plus the acceleration. To this tension, we're going to call it the maximum tension. And we also have similar, since the string didn't break for the 2.0 kilogram mass, we know that the required tension to accelerate that mass was less than 22.2 newtons. So that we will have the mass is greater than the product of the mass of 2.05 times the acceleration due to gravity plus the acceleration. Now, from this, we can solve for the acceleration because we are being asked, we think what is the range of the accelerator of the elevator acceleration. So, solving for A in both of these conditions, and here we have and with these two inequalities, we can see that the value of A must be between these two expressions, so that we will have that the acceleration is between these two. And now we can put in all the numerical values to obtain the numerical value of the interval of A. so that we know that the Tmax value is 22.2 newtons. That is the given information for this problem. We know the mass for this part is 2.10 kilograms, and the acceleration due to gravity, which is 9.8 meters per second squared, and this should be less than A. And in the other side, we'll have 2.2, 22.2 newtons over 2.05 kilograms minus 9.8 meters per second squared. So putting all of these values into the calculator, we obtain that the value of the acceleration is between 0.8 meters per second squared and 0 and 1 meter square, 1 meter per second square. So this is the interval or the range of the acceleration, so that only the masses of 2.05 and 2 kilograms do not break.